Hey there, this is Mr. Lamb. This is 4.7. These are the special right triangles. I commend you, first of all, for getting this far. I think it's fantastic that you're striving to get an A on Unit 4. So I'm really excited to be bringing these notes to you. What Section 7 is about there are two types of triangles that are really, really special in the right triangle world. And it's based on the number of degrees on their side. So let me first introduce the first of these special ones, and it is called the 45-45-90 right triangle. And what that means is it has two 45-degree angles and one 90-degree angle. So as I write down the angles here, all right, I have, let me make this a little bit smaller. Not a whole lot of room to write. My angles are 90, 45 degrees, and 45 degrees. But hopefully you know that when I have two angles that are both 45 degrees, right, or if I have two congruent angles, then the opposite sides are congruent. This is something we learned about isosceles triangles. So if I have two 45-degree angles, then the opposite sides are actually congruent. And that is going to be the first part. So if I have a 45-45-90 triangle, the length of the hypotenuse is actually radical 2 times the length of the leg. So my leg, whatever one leg is, x, the other leg will also be x. They're going to be the same number. And then the hypotenuse is going to be x times radical 2. All right, that's going to be x radical 2. And I'm going to show you an example of this here in a little bit. This means that I have, if I know the leg, right, if I know maybe the leg is 7, then I would multiply by radical 2. Right, I take 7, multiply it by radical 2, that will tell me the hypotenuse. If I know the hypotenuse and I want the leg, then I'll have to divide by radical 2. And you will see that coming up in the examples. So just give me a little bit of time to get through the theorems, and then I'm going to show you how it actually applies and how it works. So that's when it is 45-45-90. That is an isosceles triangle. The other special type is a 30-60-90. So in a 30-60-90, again, let me shorten up. I have a 30-degree angle, a 60-degree angle, and a 90-degree angle. All right, in a 30-60-90 triangle, the length of the hypotenuse is 2 times the length of the shorter leg, or the leg that's opposite of 30. So what does that mean? Well, that means that if my short leg, so as I look at my triangle, all right, my triangle has a 30-degree angle, it has a 60-degree angle, and it has a 90-degree angle. Okay, what does that mean? The 90-degree angle, since 90 is the biggest number, then that means the line I just colored in green, that will be the longest side. It's across from the biggest angle. Right? The shortest side will be across from the smallest angle. So 30 degrees across from 30 degrees. This is the short side. I'm just going to call it x. It is the shortest side. The hypotenuse will be 2 times that long. So it'll be 2 times the short leg. Now the longer leg, so the leg across from 60, is going to be radical 3 times as long as the short leg. So x times radical 3. So if we're looking at the ratio is a 1 to radical 3 to 2 ratio from smallest to largest. So again, this is going to make a lot more sense, I promise, as soon as you see the examples. So what does this mean? If you know if you have the short leg and the hypotenuse, you will multiply or divide by 2. That's short leg and hypotenuse. Why? Because the short leg is x, the hypotenuse is 2x, so the scale factor there is 2. If you have the short leg and the long leg, then you will either multiply or divide by radical 3. And again, I will show you how to do all that stuff in the coming part of this video. Okay, so two types of triangles, 45, 45, 90, and 30, 60, 90. Right, as I turn over to page 2, here are some examples with 45, 45, 90. So now I can kind of show you what I've been talking about this multiply and divide by a number. So 45, 45, 90 triangle. The first thing I like to do is I just kind of write out to the side x, x, x radical 2. All right, which means my triangle, as I look at 1A, the two legs, since it's 45, I know that this one is 45, so this is an isosceles triangle. Now it doesn't ask for it, but I know that this is 9. Well, if I were to look at this as x, x, and x radical 2, and actually for a long time I used the letter m. I call it m, m, m radical 2. Okay, so I will label on the inside, since it's 45, 45, 90, all right, I'm going to label my legs m, and m radical 2. Then the equation that I see, where is right here, there's a number. So m is equal to 9. So h, right here, is equal to m radical 2. Well, I know what m is now. So h is equal to the m value, which is 9 times radical 2. So h is 9 radical 2. And you can just leave it like that. You don't have to find a decimal approximation. But if you did, you would realize that that is bigger than m. Is bigger than 9. 9 radical 2 is bigger than 9. And it doesn't ask for it, but if I wanted to add in this leg, it would be 9 as well. Right, as I take a look at B, again, I see it's a 45. So once I know that it's a 45, 45, 90, I label my legs M, M, and M radical 2. And then I just look around my triangle. Right here is my equation. And this time M is equal to 2 radical 2. So what does X equal? Well, X equals my m value, 2 radical 2. That's m radical 2. Okay, well, what is 2 radical 2 times radical 2? Well, that's the same as saying 2 radical 4. And radical 4 is 2, so 2 times 2, that's 4. Oh, heavens to Betsy. What have I done? 4. Okay, as I look down at example 2, I'm going to do the same thing. I see that it's a 45, 45, 90. So I'll label my legs. These are M, M, and M radical 2. Okay, this time, what is it that I know? Well, I know that M radical 2 is equal to 4 radical 2. So M radical 2 is equal to 4 radical 2. And then what do I need to do? To solve for m, I need to divide both sides by radical 2. So m is equal to 4 radical 2, those radical 2's. So m is equal to 4. So what do I want to find? Well, I want to find this. I want to find x. Well, what does x equal? X equals the m value, and m is 4. So x equals 4. Another 45, 45. So m, the legs. M radical 2 is the hypotenuse. There's my number. So my little equation off to the side is m radical 2 is equal to 6. Well, I will need to divide by radical 2. So m is equal to 6 divided by radical 2. I know 6 divided by 2 is 3. 6 divided by radical 2 is a little bit different. So when I want to divide by a radical, one thing that I can do is I could multiply the top and bottom of this fraction by radical 2. And the reason I want to do that is so the top is 6 radical 2. The bottom is radical 2 times radical 2, which is 2. And then 6 divided by 2 is 3 radical 2. Right? If you need help with simplifying radicals, just ask. I can sit with you and help you with that. And I'm going to show you a couple of different techniques throughout this video that I do. And I actually have one of them that I kind of like that makes life a little bit easier when you have that radical 2 over there. So what does x equal? Well, x is equal to whatever I found for m, and I found m to be 3 radical 2. And again, that is some sort of a decimal if you needed to find that. All right, so that's when I have a 45, 45, 90 triangle. I know that the hypotenuse is radical 2 times bigger than either of the two congruent legs. Okay, well, when I go to a 30, 60, 90, I'm still going to do the same kind of thing. I'm still going to talk about this m. Except now it was 1m, radical 3m, and 2m. That's what I'm going to label. So I find my 30-degree angle first. And across from 30, over here, is m. Across from 90 is 2m. And across from 60 is m radical 3. And then it says, I just first find my m. In this case, m is equal to 5. So now to solve this triangle, I just plug in. So the hypotenuse is 2 times m. So up here, 2 times 5 is 10. And the long leg is m times radical 3. So 5 radical 3. The triangle has been solved. And as I look at 1b, across from 30 is m. Across from 90 is 2m. And across from 60 is m radical 3. Well, here's my number, 14. It's on the 2m side, so 2m is equal to 14. So if I wanted to solve for m, divide both sides by 2, and m is 7. That means my short leg up here is 7, and my long leg, y, is m radical 3, or 7 radical 3. And my last one, this is my 30 over here. So across from 30 is m, across from 90 is 2m, and m radical 3. So my equation, here's my 5. So m radical 3 equals 5. And to solve this for m, my little shortcut is pretty simple. When I do these kind of problems, I'll take m, 5, and I just move my radical to the right. So 5 radical 3 over top of the number inside the radical. So 5 radical 3 over 3. And if you want to see, as we kind of look up here, if I go all the way back to that example where I had m radical 2 equals 6, I could have just called that 6 radical 2 over 2. So I could have just kind of shortcut it. Anytime I see that radical, my little trick is m radical 3 equals 5, move the radical over 5 radical 3, and then put whatever's inside the radical underneath the 5, and that'll do the same kind of thing. So if m is equal to 5 radical 3 over 3, well, what is d? This distance right here is m. So this distance is 5 radical 3 over 3. And this distance over here, f, is 2 times 5 radical 3 over 3. And what is 2 times 5? That's 10 radical 3 over 3. That's the answer for f. So that triangle is a 5 radical 3 over 3, 5, and 10 radical 3 over 3. And lo and behold, if you were to do Pythagorean theorem to those 3 sets of numbers there, even with all the radicals, the Pythagorean theorem would work. They're not triples, but they do make a right triangle. So a couple of practice problems here. Problem number 1 says a high school softball field or softball diamond is a square. So let me put a square up. All right. So there's a softball diamond. And if you know anything about softball, this is home plate. All right, and I go down here, this is first base, and I go up here, and this is second base, and I go over here, and this is third base. And it says the distance from base to base is 60 feet. Okay, so this is 60, 60, 60, 60. To the nearest foot, how far does the catcher throw the ball from home plate to second base? So if I wanted to find the distance from home plate to second base, well, this makes a triangle. That's 90 degrees. If it is 60 and 60, then this is a 45, 45, 90 triangle. Now, some of you would say, well, can't I just do Pythagorean theorem and do a squared plus b squared equals c squared? You could. But there is a shortcut, and any time, especially those of you striving to get an A right now, I want you to know the shortcut. Since this is a 45, 45, 90 triangle, this means my sides are m, and the hypotenuse is m radical 2. So in this case, this distance that the catcher must throw, if m is 60, right here, it says m is 60, then that distance is m radical 2. So 60 radical 2. Well, now it wants it to the nearest foot. So 60 radical 2. Let me grab a calculator. Calculator is right there. Just a second while this thing loads up. So 60 radical 2. So 60, the square root of 2. I need to round this to the nearest foot. Looks like 84.9 feet. 84.9 feet. Oh, it wants the nearest foot. So about 85 feet. About 85 feet from home to second base on a softball diamond. If you wanted to do an example on your own, a baseball diamond is not 60 feet from base to base, it's 90 feet. So you could go ahead and try that one and do 90 around, and 90 radical 2, I think is about 127 if I remember from my high school baseball days. So 90 radical 2 is, yes, 127.27 feet. I remember a coach telling me one time to throw the ball 127 feet, not 125 feet, when I was playing catcher. All right, and then question number 2 says, an artisan makes pendants in the shape of an equilateral triangle. Okay, well, I'll put in an equilateral triangle. And one thing I know about equilateral triangles, if they're equilateral, they're equiangular, so they are 60, 60, and 60. And it says the height of the pendant is 18, so the height is actually this distance right here. So this height is 18. Well, if you think about it, this makes a 90, 60, and now this top angle, if the whole angle were 60, I just cut this into two 30s. So now I have a 30, 60, 90 triangle. So I'm going to use my shortcut again. Well, my short side across from 30, this one down here is m, hypotenuse is 2m, and this is m radical 3. So my equation is m radical 3. The long leg equals 18. Again, using the little shortcut, that means m is 18 radical 3 over 3. And 18 divided by 3 is 6. So 6 radical 3. So I want to know, what is the length of the side of the pendant? Well, m is 6 radical 3. The length of the side is right here. The side of the pendant is 2m. So one side is equal to 2m. Well, I know m. That is 2 times 6 radical 3. Well, 2 times 6 radical 3 is 2 times 6 is 12 radical 3. And it wants this thing rounded to the nearest tenth. So 12 radical 3 rounded to the nearest tenth is 20.8. So 20.8 millimeters would be one side. Types of problems that you might see doing this, you might see someone ask you to find the perimeter of that triangle. So then you have to do the 20.8 and add it up 3 times or something crazy like that. But that is real world applications of when it comes in handy to do the special right triangle. Some of you may be wondering, if you are right now thinking, well, can't I just use SOHCAHTOA? Can't I just use Pythagorean theorem? Yes. Yes, you may. That's absolutely what you could do. But the difference between a B student and an A student is an A student will be able to do these shortcuts. If you are okay with solving these problems the other way, that's fine. Just understand that being a master of the special right triangles means that you know how to manipulate the special right triangles. So right now, if you want to pause the video, you may pause the video and do the check what you've learned and check and see. You do have one 45-45-90 triangle and the other one is a 30-60-90. So go ahead and press pause and give them both a shot. Okay, and here we are taking a look at the 45-45-90 triangle. My legs are m. The hypotenuse is m radical 2. So first find m. Well, right there's my number. 7 is m. m is equal to 7. So to find x, x is equal to m radical 2. Well, I know m now. m is 7, so 7 radical 2. That is x. In example B, I have 30-60-90. Short side is m. Hypotenuse is 2m. Long leg is m radical 3. So here's my number 6. It is on the 2m side. So 2m is 6, which would make m 3. So where is x? X is equal to m. And in this case, m, we just said, was 3. So x is equal to 3. And that is how you use the shortcut for special right triangles. Hope you got something out of the video. Good luck.